Hi, let's do some calculus. Woo, woo, woo. Don't be scared. This isn't too bad at all. So this is about derivatives of inverse functions. So in previous courses, including even Algebra 1, you would have learned about inverse functions. And what they are, it's denoted as, let's say for the function f of x, f inverse looks like this. This does not mean that f of x has an exponent of -1. This is just the way we denote f inverse. So this means the same thing as me just saying f inverse. F raised to negative first power, even though it's not at all. It looks like that, just f inverse. Numerically defined to be, and this is going to be a little bit, I don't even know how we say this, elementary, the way that I'm going to say this. The input and output are switched. And I already filled in some stuff down in the next row you can see over here, but the graph of f inverse is a reflection of the graph of f over the line y equals x. So the line y equals x equals here. So if there's something here on the graph, it will be down here. So everything is a mirror image or a reflection over the line y equals x. The domain of f of x is equal to the range is equal to the domain. So everything is just flip-flopped. If I want to represent analytically, meaning using algebra, f of f inverse of x. So I've got this function inside of another function. Oh, we might get to do chain rule today. F of f inverse is equal to f inverse of f of x. So this is not multiplying, it's a function within a function, so f of x is inside of this one. If you do this algebraically, we just get x. So, and I could convince you of that, but it would take a lot longer and I don't want to spend your time doing that, but please ask me and I can convince you of this. We could figure out the function, I don't know, let's say y equals 2x plus 3. I've got this function and then I switch x and y. So I switched x and y. I solve for my new y. Divide by 2. Y is equal to 1/2 x minus 3/2. I said I wasn't going to do it and then I got excited. These two functions are inverse functions. The x and the y switch. If I would do, if I say call this one f of x and then this one f inverse of x, you can try substituting in everywhere you see an x. You could try substituting in 2x plus 3, and this one you could try substituting the 1/2 x minus 3/2, and what you're going to get when you simplify all that out is x. It doesn't matter which way that you do this. So I have f of f inverse is x and f inverse of f of x is x. This is important because this is how we're going to figure out a derivative, but for right now, that's all we need. The next thing is, so it says consider the two functions f of x and g of x represented numerically below. So we have a table. Woo, a table. And then it says just complete the table of values. So this doesn't have anything to do with calculus. It's just us being convinced that this works. So if this is x and this is f inverse, what I'm going to do is I'm going to take these two and I'm going to say, you know what, my y value, my domain, becomes my x. And my x value becomes my range or my y. Same thing with the next one. I would say 2, 1. So x's and y's switch. If I want to do the next one, complete the values of the table, and this is g inverse. This is my x, this is my y for g of x. I switch them. So this would become 1, -2, and -2, 1. I'm switching my x and my y values from my original g of x function. Now this is just practicing. So again, no calculus yet, sadly. I'm just figuring out, well, what is g inverse of -2? You could go to the table we just made, or you could think, you know what, I've got g of x in this table up here. I'm not looking at my x value anymore. I'm looking at my y value. -2, just to make sure that I'm right. Oh, yep, I'm good. I should be getting this value of 1. So whenever you're dealing with composite functions, you're working your way inside out. And I'm going to say f of 1. And then I can find the function value at 1. This is just f of x, so I'm going to look typically like I normally do. I've got f of 1, which is 2. My next problem, it says f inverse of f of 1. So f of 1 is just regular. Remember, I'm working inside out, so f inverse of f of 1. F of 1 is 2. F inverse of 2, if I was looking up here, and again, I just did this down here so I can check myself in a minute, but F inverse of 2, I'm not looking at my x value, and there's not even one there. I'm looking at my y value because they switch. So 2, my function value for my F inverse at 2 is 1. In the next one, you try it. What's F inverse of 2? F inverse of 2, I'm going to go up here, I'm going to look at my y value, and then I go to my x for f of x, and I get 1. If I want to check myself to make sure that I was right, I could do it down here. But most of the time, you're just going to be given something like this. So if you want to get used to doing this. Okay, g inverse of 1, I'm going to go up here, and instead of looking at my x value, I'm going to look at my y value. 1, I would get negative 2. Last one. This one has a function within a function within a function. We do it a couple times. So what I'm going to start is here. I'm going to say g inverse of g of whatever I get on the inside. So g inverse of 1. G inverse of 1 is going to be, this is 1, there we go, we get negative 2. Then the next thing, I'm still working my way inside out. So I'm going to have g inverse of g of negative 2. G of negative 2, this was just a regular g of x, so negative 2 would be right here. I'm going to go back to 1. G inverse of 1, so think about it's asking about the inverse for g, so I'm going to look at the y value, negative 2. Ta-da! Let's do more. Hopefully there's calculus on the next page. I know that's probably what you're thinking too. I see something that says differentiate. Woo! So this one says I'm going to find a formula for the derivative of the inverse. So I'm not just going to tell you this one right away, because if you forget it later, you're going to be able to come back to this knowing that f of f inverse is equal to x. What I want to do is differentiate both sides. And so what I just said was this was a composite function. There's a function within a bigger function. Wow. I wasn't angry. That was just how my face goes when I make that noise. Wow. Okay, so what you're going to do is you're going to take the derivative of the outside. This is the chain rule, which would be f prime. We leave the inside alone. F inverse of x times the derivative of the inside. The hardest part about this is dealing with all of something raised to a power and all the notation. So f prime, I left the inside alone, times the derivative of the inside. Well, the inside was f inverse of x. The derivative would be prime. Looks crazy, that's okay. On the right-hand side, we haven't done this before, but the derivative of x is just 1. So normally we don't have an equation that looks like this. It just has f of x on one side, but soon you're going to have more of those with implicit differentiation. Okay, so we've got 1. If that scared you, don't let it. You're just going to have more friends that way when you can talk like that. Okay, so we've got the derivative of x, which is just 1. What I want to do is I'm really looking to find out what is the derivative of this whole mess, the f inverse, the derivative. So what I'm going to do is on both sides, I'm going to divide by f prime of f inverse of x. And you could be using parentheses here. I'm just using a different grouping symbol. So that means we just found a formula. F inverse of x. To find that derivative, what I would do is 1 over f prime of f inverse of x. Ta-da! This is what we were looking for. And now I can use that. So this one says, suppose that f of x is equal to 3x plus 2, and f prime of negative 2 was 3. What's the value of f inverse of negative 4? So f inverse of negative 4 and this says prime, so what's the derivative? So prime equals, and I'm just going to go up here and use this. 1 over f prime of f inverse of this one of -4. That would be 1 over f prime. Okay, f inverse of -4. This is where we've got to like think through this a little bit. All I've got is f of x. Oh no. So if all I have is f of x, and I know y is equal to 3x plus 2. What you could do first is you could switch this x and y around and then solve for y, and then you would get the inverse function. Or if you're like, you know what, I know that this would just be x equal 3y plus 2. There's no reason for me to solve this right now. I can solve in a minute. I just want to substitute in -4 into here. I want to see like, okay, f inverse of -4. This would really mean, or you could have said here, knowing the x and y's are switched, you would say -4 in for x. Because remember, this was the inverse function. This is the inverse of f. And then I'm solving for this y value. And so I would get to subtract 2 on both sides. I get -6 is equal to 3y. Y divide by 3 on both sides. I get -2. Whew, we did it. F prime of -2. F prime of -2 is given to me. That's so nice. Also, we could have figured this out because the slope of the tangent at any point is going to be 1/3. I'm sorry, not 1/3. The slope is going to be 3 because y equals mx plus b. So this part didn't even really need to be given to me, but it's a gift. So we've got 1/3. If we were just saying this is fun because I just told you that the slope of f of x is always 3, if we would have kept going with this and I said x is equal to 3y plus 2, and we actually would have solved for y, subtract 2 on both sides, I would have gotten 3y is equal to x minus 2. Divide by 3. 1/3 x minus 2/3. This is the equation for the inverse of f of x. Do you see how the slope is always 1/3? So regardless of what number we would have chosen, we still would have gotten this to be 1/3. This is just like before. Sometimes we'll get a function for this, sometimes not, depending on if we're given just a line in the original problem. Okay, let's keep going. Oh, this is gross. Do you see this? We've got f, g, f prime, g prime, and by gross I mean awesome. This is asking me to find the derivative. So you see this little apostrophe at the top. This is the derivative of f inverse of 3. So f inverse of 3, the derivative I know is 1 over f prime of f inverse of 3. And again, I'm just looking at this from up here. This would be 1 over f prime, and then I have to go up to my chart. I don't have f inverse in here, so what I need to use is just this function f. F inverse of 3 would be, remember the x and y's are switched, so I need to go down to where my y value for f is 3, and then I need to look at my x value, and I get 1. Now this is easy peasy lemon squeezy, not difficult, lemon difficult. F prime of 1, this is f prime at 1, which is 2. And we get a slope of 1/2. Next. The next one says g inverse of -2, and I want the derivative because I can see this little apostrophe up here. So I want the derivative is equal to 1 over g prime of g inverse of -2. And again, just following this 1 over f prime of f inverse, but these are g's, so we're going to go there. 1 over g prime, g inverse of -2. So I don't have g inverse on here, so what I need to do is look at g, and then I need to look for -2 as a y value. There it is. My x value is 1, which means inverse would be switched. We got this. We got g prime of 1, which would be 1 over g prime of 1. This is g prime. I'm going where x is 1. I get 1. 1 over 1 is just 1. This is accidentally from the next page. So this business down here should be on page 96. I already did that, but take a moment and you should do that now. So this is the columns X, F, G, F prime, and G prime. So sorry about that. In this one, F and G are differentiable functions. That's nice, so I know that they're continuous also. And selected values and their first derivatives, F prime and G prime, are shown in the table below. Nice. And by below, we mean above. That's what I meant. Usually when people say below, they mean above. Use this table of values to answer the questions to follow. Okay, so this one says G inverse of 1, but I'm taking the derivative. So I want the derivative. Find the equation of the tangent line. Oh, that's so fun. It's like coming back to an old friend. So what are the two things that we need? A slope and a point. Slope of the tangent, also known as derivative. That's what I'm finding. So this would be 1 over, and again, you're using this rule from the first page. If I move it this way. 1 over G prime of G inverse of X, or in this case 1, which I would get 1 over G prime. G inverse, again, I don't have a G inverse here, so I'm going to look at G. I'm going to look where the Y value is 1, and I get 3 as my X value, or my G inverse of 1. 1 over G prime of 3. G prime of 3, this is just typical, so look at the X value, and then go to the Y. I get a slope of -1/2, which means if I'm writing my equation of my tangent line, I get Y minus Y1 is equal to M. And I did that part. And then I get X minus X1. And now it's a little bit tricky to think about this, but you're smart, so I'm pretty convinced you'll be fine. This one says, find the equation of the line tangent to G inverse. That's why we found the derivative of G inverse. That also means when X is equal to 1, so G inverse of 1 equals what value? So when you get your point, you should be thinking about G inverse, because this is the equation of the line tangent to G inverse. So if I have 1, I'm going to go up here, G inverse of 1, I'm going to look for my Y value, I get my X value of 3. And I have a slope and a point. Y minus Y1, so Y minus 3 is equal to M times X minus X1. Ta-da! Let's do 2 more. Estimate the value of F prime of 2. Wait a second. That has nothing to do with these inverse functions. How do you estimate a derivative? It's just because we have a table and this is a good chance. So why not estimate the derivative right here? Okay, so if I'm estimating a derivative, the derivative is the slope of the tangent for this problem at x equals 2. It's the slope of the tangent of f of x. If I can't get the slope of the tangent and I have to estimate, what I want to do is find the slope of the secant. Make sure that you're using f and not f prime, because you're finding the slope of f between two values close to 2. I can see the values close to 2 here. I've got 1 and 3. It's really important that you show this step so I know where you're getting these numbers from. F of 3 is 1. F of 1 is F of 1 is just 3. So I'd have -2 over 2, which is -1. I want to make sure that I'm right on this one. Oh, I changed a couple things. Okay, so if this is f prime of 2, and I just want to make sure that I'm right. So I said f of 3 is 1. F of 1 was 3. I think I said that weird, but either way, I've got 1 minus 3, -2 over 2. Yeah, I'm good. And then this one says, show what conclusions can be reached about the graph at x equals 2. So the graph at x equals 2, and this is where I am right here. I could just say, because the derivative is negative, so f prime of 2 is less than 0, so it's negative. Therefore, so 3 little dots look like a triangle, f of x is decreasing at x equals 2. Next one. Oh man, this doesn't even have to do anything with inverse functions again. Again, it's just good practice. So this one says g prime of -1. So you try this one. If I can't get the slope of the tangent, I'm going to get the slope of the secant. I'm going to pick 2 points close to -1 on the graph of g because I'm finding the slope. At g of -1, I'm going to pick between -2 and 0. If you said g of -2 minus g of 0, that's fine too. But whatever you do in the denominator, make sure that you've got, like it goes in the same order. So if you put it in this order, make sure you don't switch the -2 and 0. G of 0. G of 0 is -3. G of -2 is 2. I would have -5 halves. Woo! Based on this value, what conclusion can be reached about the graph of g? And I'm going to say g is decreasing. And I have to make sure that I say at x equals -1 as g prime of -1 is less than 0. And I think that's it for this. So thanks. Sadly, we're not going to do more with it. Well, at this point, don't worry, you'll have more otherwise. But right now, I think that's about it for the derivative of inverse functions. If you have any questions, please reach out. I'm so thankful to teach you. If you need anything from me at all, let me know. Okay, bye.